Okay. Oh man. Alright. I'm like, it's recording the right thing, except you guys can't see the right thing. Poor Mr. Bentley this morning, his projector was upside down. Yeah, that's what he said. He comes running over, he's like, my projector's upside down. I was like, that's really funny.
So how did he do it? How did he fix it?
I Googled it.
Because I would like to know that.
You just flip the projector the other way around.
Yeah, just turn it upside down.
No, literally, it's on there.
There's a button on there?
There's a button.
Okay.
But it was really funny. So he's like, I don't know. I was like, I don't know. I never seen that happen before. And I could turn my video upside down on OBS, but I don't know how to do it on the projector. It's awesome. He comes over and I tried all the buttons.
I pressed all of them.
I also fixed Mrs. Downer's website too this weekend.
Yeah.
I was like, yes!
Why does everyone come to you for that? Google site.
That is same person.
I know enough to be dangerous. I know typically enough to break stuff, not necessarily to fix it.
Yeah.
So, like, because I've broken stuff before, I just go through the process by which I try to fix it, and then I'm like, okay, look, it fixed. That's actually how I fixed my webcam. I restarted my computer. All right. So, the chain rule. Now, let's be clear. Like, I have said that this is terrible. You're going to be like, huh, maybe not so terrible. Trust me, you're in the delusional phase. Because it won't feel as bad as I've made it out to be until you get to a point where you have to decide if you have to do chain rule or not. That's the issue. That is literally the hardest thing to do. Okay. But this actual whole process of, like, when I tell you, hey, use the chain rule, you're going to be like, oh, yeah, okay, I know I have to find an outside and an inside function. It's just an issue when it's all jumbled up. Okay. So, what we did in 2-9b, which was example 2, which is the most important thing, is chain rule is called the outside-inside rule. Meaning you take the derivative of the outside, and then you take the derivative of the inside, and you multiply them together. So the idea is that you have to identify, like nesting dolls, a nesting doll situation. A bigger doll, a smaller doll, a smaller doll, a smaller doll, so on and so forth. I'll send you guys a thing that I found, because I don't think it's in.
I think it is.
Is it in 2-11?
Yes.
The image?
In the Discord last night.
Oh yeah. But that's the only thing that they learned in Calc is to differentiate the mom and then differentiate the baby. So bad.
Someone said this is what we're coming up to tomorrow, and I'm like,
Yeah. Okay. So your outside function is 3x squared plus 4x plus 7. Now you guys know what I do like on my spare time. Is I like look for like stuff like that. It's really sad. Okay. My g of x is my inside function, which is x plus 2. Now all of these that we're going to do today are related to polynomials. Everything that's nice and pretty. Tomorrow is trig and logs. I know, right? We're like, and I'm out.
we have one day.
Guys, I will not be here.
What's the article on that?
Yes.
They're working on that.
Yes.
Correct ways to do this?
No.
No, not even sometimes.
Well, okay, let me rephrase that. When you can multiply something out, like in this situation, yes, you could multiply it out, distribute, do power rule, and not touch chain rule at all.
Yes.
85% of the time, you have to do chain rule. And the only way that you can do chain rule, even though all the BC people will like to make up their own rules to the game, the only way you can do it is take the derivative of the outside and multiply by the derivative of the inside. The other issue that comes up is if you have multiple insides. So you have an outside, an inside, and another inside. Yeah. Well, no, it will. Trust me. Wait till we do this. Well, and here's the thing, like, in the end, this is going to seem like, oh, not too bad. Then you're going to look at the Google form and be like, what happened? Don't do the Google form. Don't do the Google form at home. Do it here. Okay. So, to take the derivative, we have to identify the outside.
X cubed.
Good. And then you have to identify the inside. So, you take the derivative. Now, granted, you can multiply this out 3 times, or you can do binomial theorem that nobody remembers. One, 2, 1.
Yeah, I know. I used that.
Pascal's triangle.
Yeah, I remember that one. We did not forget.
I forgot.
Okay. So you take the derivative of the outside function. So you bring down the 3, and then you have the parentheses to the second power. What goes in the parentheses is still your inside function. It is still 4x plus 3. Then you multiply by the derivative of 4x plus 3, which is 4. And that's it.
Wow.
Yes.
What was the first 3?
For bringing the exponent down.
I just sort of said.
So we're doing dy over dx equal to dy over dx. So it's just, okay, I need
That means
to
it's
times 3.
F1 DFS times F and DFS.
So essentially what you're doing is f prime of g of x times g prime of x. We'll talk about the dy over dx thing later because that requires implicit differentiation. Okay, so y prime is 12 times 4x plus 3, the quantity squared, and then somebody's about to ask me whether or not they have to simplify. No, you can leave it like this.
Yes.
Yeah. Oh, let's go, baby.
All right, questions?
Could we do like this AP test?
Yes.
Because algebra and I failed.
Yeah. The algebra's about to get, like, it's going to start getting more difficult. Not gonna lie. The arithmetic part gets a little bit more difficult. You're going to be like, oh, 3 times 3 is 27. Because you're going to do 3 cubed instead. You know what I mean? Like, especially with derivatives. Like, that is the most commonly missed thing, is something like that. And I do it all the time. I'm not immune to it.
Why did they force no calculus? We have a walking calculator.
Oh, yeah, that is 7.
If we had no calculator.
Yeah.
2/3 of your AP test is without a calculator.
Wow. And what part of my life is without a calculator?
Okay. We just play by the rules.
Somebody.
Alright. Well, you would think that they would change the rules at some point when the SBAC has a calculator for the entire thing.
Yeah. But AP versus California.
Okay. But that would also require like changing and like a lot of review and also AP classroom.
Okay, well, it happened in the lane test.
Huh?
It happened in the lane test a couple years ago. And now it's kite.
Okay. Outside function is something to the 6th power. So I have 6, something to the 5th power. And then I multiply by the derivative of the inside, which is 3. So y prime is 18.
That's it.
Most commonly made mistake is to accidentally put the derivative inside the inside function instead of the function itself. Don't do that. It is, you leave the function alone. Yes.
Can I take the inside function and make it variable?
If you want, that's a lot of effort. You still have to replug it back in. Oh. Hey, I majored in math for a reason. You could read that and I can tell you why I did not major in English. That is a perfect example of why I did not major in English. Alright. Your outside function is your square root. Your inside function is what's underneath the root.
Yes.
I would rewrite this to the 1/2 power.
Yes.
Just like I did everything else. And then I take the derivative. So I bring my 1/2 down to the negative 1/2. I fill in my 3x squared minus x plus 1, and then I multiply by the derivative of 3x squared minus x plus 1. 6x minus 1. And we're going to leave it.
Yay!
Yeah!
Daniel?
No more work. No more work.
I was
Okay.
trying to speak and that was fun.
I will tell you that it is to your benefit knowing the Google form versus the grades to for you to start the Google form in class. Because there were already questions in 0 periods, so I'm just saying. Okay. The outside is the cube, the inside is the x squared plus 1. So y prime is 3 something squared, which is your x squared plus 1, times the derivative of x squared plus 1, which is 2x. So y prime is 6x, x squared plus 1, the quantity squared.
Yay.
Yay! Question. Trig is worse. It's always worse. And so are logarithms. And the only reason why those are worse is because there's identity. Alright, you guys have the rest of the class